Troubleshooting and Repair Techniques, Welcome and Overview. Hello folks, welcome to this lesson on troubleshooting and repair techniques for electrical and electronic systems. This lecture is designed to provide you with the foundational knowledge necessary to effectively identify, diagnose, and repair issues within these systems. This lesson will be especially beneficial for those working in environments where electronic systems are prevalent, offering a structured approach to problem solving and repair. Introduction to Troubleshooting and Repair Techniques for Electrical and Electronic Systems. Importance of troubleshooting skills. Troubleshooting is a crucial skill in the field of electrical and electronics engineering. The ability to quickly identify and resolve issues not only improves productivity but also enhances system reliability and safety. Effective troubleshooting can prevent minor problems from escalating into major failures, saving both time and resources. Let's explore the systematic approach to troubleshooting that can help you become proficient in resolving electrical and electronics issues. Understanding electrical and electronic systems. Before diving into troubleshooting techniques, it's important to have a basic understanding of electrical and electronic systems. These systems can range from simple circuits to complex networked operations. They generally consist of power sources, conductive pathways, loads, and control elements. Understanding how these components interact is essential for effective troubleshooting. Core components. Power source supplies energy to the system, for example, batteries, generators. Conductive pathways routes current through the system, for example, wires, PCB traces. Loads. Devices that consume electrical power, for example, motors, lights. Control elements, devices that manage the operation of the system, for example, switches, relays. Troubleshooting process. The troubleshooting process involves a series of logical steps designed to isolate and resolve problems. Let's go through these steps. 1. Identify the problem. The first step is recognizing that a problem exists. This can be prompted by abnormal system behavior such as unexpected noises, smells, or performance issues. Documentation and operational logs are valuable in this step, providing baseline information about the system's normal operation. 2. Gather information. Collect all relevant data about the symptoms and operating conditions at the time of failure. Interview users or operators to gain insights into when and how the issue began. Use schematics, diagrams, and technical manuals to understand system layout and functionality. 3. Develop hypotheses. Formulate potential causes for the observed symptoms. Consider environmental factors, recent changes to the system, and common failure modes. Hypotheses can guide diagnostic testing. 4. Test hypotheses. Employ diagnostic tools to test your hypotheses. Use methods such as voltage measurement, continuity testing, or signal tracing to confirm or refute potential causes. Keep safety in mind and use appropriate personal protective equipment (PP). 5. Implement solutions. Once a cause is identified, apply corrective actions. This could involve replacing defective components, repairing connections, or adjusting system settings. Check to ensure the solution resolves the issue without introducing new problems. 6. Verify and document results. After making repairs, test the system to verify the solution's effectiveness. Document the root cause, actions taken, and results achieved. Documentation helps in future troubleshooting efforts and continuous improvement. Understanding diagnostic tools and methods. Understanding and using diagnostic tools effectively is key to successful troubleshooting. Here are some commonly used tools and techniques. Multimeter. The multimeter is an essential tool for measuring voltage, current, and resistance. Learn to use it safely to identify open circuits, short circuits, and improper voltages. Oscilloscope. An oscilloscope enables visualization of electrical signals over time. It's useful for diagnosing timing issues and examining waveform integrity. Signal generator. A signal generator provides test signals to validate system responses, particularly useful in communication and audio systems. Diagnostic software. For complex or software-driven systems, diagnostic software can automate the identification of control system faults or misconfigurations. Common troubleshooting scenarios. Let's discuss common scenarios and techniques associated with troubleshooting intermittent issues. These issues come and go, making them challenging to diagnose. Focus on identifying patterns or external influences that may trigger the issue. Electrical noise. Unwanted interference affecting circuit performance can be diagnosed with an oscilloscope or specialized noise meters. Address grounding and shielding to reduce noise. Component failure. Components like capacitors, resistors, and semiconductors can fail or degrade. Use component testers and visual inspections to identify faulty parts. Active learning exercises. Practice using a multimeter on a variety of circuits, measuring voltage and continuity. Simulate common faults in a controlled environment and perform troubleshooting exercises. Analyze a case study of a past troubleshooting scenario and propose alternative solutions based on the current knowledge. Here's a summary. Introduction to Troubleshooting and Repair Techniques for Electrical and Electronic Systems Overview. Troubleshooting and repair involve identifying and fixing faults in electrical and electronic systems. Troubleshooting steps. 1. Identify symptoms, recognize system malfunctions or errors. 2. Gather information, collect data on system configuration and history. 3. Analyze data, use data to identify potential causes. 4. Isolate faults, use testing and measurement to pinpoint faults. 5. Repair or replace, fix or replace faulty components. Troubleshooting techniques. 1. Visual inspection, look for signs of physical damage or wear. 2. Measurement and testing, use multimeters, oscilloscopes, and signal generators. 3. Signal tracing, follow signal paths to identify faults. 4. Fault isolation, use techniques like divide and conquer to isolate faults. Repair techniques. 1. Component replacement, replace faulty components with new ones. 2. Wiring and connector repair, fix or replace damaged wiring and connectors. 3. PCB printed circuit board repair, repair or replace faulty PCBs. Safety precautions. 1. Personal protective equipment, wear protective gear like gloves and safety glasses. 2. Electrical safety, ensure proper electrical connections and avoid electrical shock. 3. Static electricity protection, use anti-static devices to prevent damage. Common faults and solutions. 1. Open circuits, identify and repair broken connections. 2. Short circuits, identify and repair unintended connections. 3. Component failure, replace faulty components. Best practices. 1. Documentation, keep accurate records of system configuration and repair history. 2. Testing and verification, thoroughly test systems after repair. 3. Continuing education, stay up to date with new technologies and techniques. Here's a summary. Understanding electrical and electronic systems. Key concepts. 1. Electrical systems use electrical energy to perform tasks, for example, lighting, heating. 2. Electronic systems use electrical energy to process information, for example, computers, communication systems. 3. Circuit analysis, study of electrical circuits to understand behavior and performance. Electrical system components. 1. Generators, convert mechanical energy into electrical energy. 2. Motors, convert electrical energy into mechanical energy. 3. Transformers, change voltage levels in electrical systems. 4. Circuit breakers, protect electrical systems from overcurrent. Electronic system components. 1. Microcontrollers, small computers that control electronic systems. 2. Integrated circuits, miniature electronic circuits on a single chip. 3. Diodes, control flow of electrical current. 4. Transistors amplify or switch electrical signals. System analysis and design. 1. Circuit design, create electrical circuits to perform specific tasks. 2. System modeling, represent complex systems using mathematical models. 3. Simulation, test and analyze system behavior using software tools. Applications. 1. Power systems, generate, transmit, and distribute electrical energy. 2. Communication systems, transmit and receive information through electronic signals. 3. Control systems, monitor and control physical systems using electronic signals. Benefits. 1. Increased efficiency. Electrical and electronic systems optimize energy use. 2. Improved productivity. Automated systems enhance productivity and accuracy. 3. Enhanced safety. Electrical and electronic systems provide safety features and protection. Conclusion. Troubleshooting and repair are essential skills for ensuring the reliability and performance of electrical and electronic systems. By understanding the fundamental components, applying a systematic approach, and utilizing appropriate tools, you can effectively identify and resolve issues. Remember, practice and experience play significant roles in becoming proficient in these techniques. Thank you for taking this lesson on troubleshooting and repair techniques. We hope to see you in the next lesson. Happy troubleshooting!